Good morning, my dear students. Welcome to online classes. Today we are going to discuss about one of the important and interesting concepts. Every electrical student must be know about these concepts because of these are the basic concepts for our applications, electric power transmission system and electrical machines. That is the concept of inductance. In the second unit, we are already discussed regarding to the resistance parameter and capacitance parameter. Now, in the third unit, we are going to discuss about the concept of inductance. So here, inductance is the property of inductor. So now, what is inductor? In the first year, we are already discussed the basic passive components. Those are resistor, inductor, and capacitor. Now, in that, what is an inductor here? This is used in a variety of electrical machines for their designing. So now inductor means a wire of certain length can be twisted in the form of coil that can be constitute an inductor as shown in figure. Figure like this. That means here this is an inductor which is in the form of coil. So that's why inductor means it is a coil which has n number of turns. These are called number of turns or n number of turns. Now we can go to the property of inductance. What is inductance here? Means here inductance is the property of inductor. What is that property? See here. Inductance is the property of inductor by virtue of which it can opposes sudden changes in current. So this is the basic property of inductor. So here the properties which can opposes the sudden changes in current. That's why inductance is also called as electrical inertia. Because of the inertia can opposes the rotational motion. That's why which is compared with inertia. The inductance is called as electrical inertia. And the units of inductance are henries. So inductance is represented with L. That's why here it is L. Now we are going to discuss about the expression for inductance or self-inductance of a coil or inductor. So now, self-inductance of a coil or inductor, because of coil or inductor both are same. So now see here, let us consider a coil of n turns. As shown in figure A. So that means this is inductor which has n number of turns. Now in that, let I be the current flowing through coil. So whenever a current flowing through the inductive coil which can establish a magnetic flux, like this around the inductor. This is a magnetic flux which can establishes a magnetic flux phi, and this magnetic flux phi can links with the n number of turns, then flux linkages are formed. Then flux linkages are formed. These flux linkages are proportional to the current through the coil. These flux linkages are proportional to the current through the coil. Then the flux linkage is represented with psi. Psi is equal to flux linkages, that is equal to n phi. So and this flux linkages are proportional to current. Whenever current increases, the flux linkages are also increases. Whenever current decreases, the flux linkages are decreases in an inductive coil. So now if we can remove this proportionality constant L here, so then from this L is equal to n phi by L, where L is the inductance or self-inductance of a coil expressed in henries. So where L is the self-inductance of a coil, where L is the self-inductance of a coil or inductor. So how to define this definition? So here n phi means flux linkages, I means current. The flux linkages per unit current of an inductor is called its inductance. The flux linkages per unit current. Here the flux linkages per unit current of an inductor is called its inductance.